Chris Sosha, and I'll be demonstrating for you some principles of physics. I hope that I make them fun, and I hope I illustrate them all. Please enjoy the demonstration. Thank you. Okay, for my first experiment, all you need is a light ball, such as a ping pong ball or a styrofoam ball or anything that has a light weight, and a regular home hairball jar. I'd like to show that this ping pong ball could actually be balanced on the jet stream of the hairball jar. Doesn't seem logical. You think that, well, if I turn it on, a ping pong ball is going to go flying. But according to Bernoulli's principle, the pressure of the jet stream is less than the pressure of the surrounding air. So, we put the ball on, it stays. Because when the ball wants to turn, it's pushed back onto the hairball jar, so it will never leave the jet stream. Pretty cool, huh? Okay, for this experiment, all you need is a candle, matches, or a lighter. Now you want to set up the candle in a draft-free environment as I have here. And I've so far lit the candle and it's been burning for about 1.5 minutes. You want to let it burn for about 1 to 2 minutes. Now, at the end of the experiment, I keep my lighter lit, just in case. You want to blow out the candle, get the lighter near. Don't touch the thing. Don't touch the candle with the lighter. As you can see, with just getting near, the candle relights itself. So, the flame actually travels down the smoke as long as there's a very short period of time between blowing out the candle and getting another flame in contact with the smoke. In this time period, if it's longer than about 2 seconds, the flame will probably not travel down the smoke and reignite the wick. So, this experiment shows the findings of Dr. Sanders of the Chemistry Department of Salt Lake City Community College Redwood campus. He was consulted as to the flammability of smoke. He said smoke may be flammable because of unburned particles in the smoke being able to reignite. But he also stated that smoke is definitely a very good heat conductor, which it is. So, my conclusion is that by blowing the candle out, there's a high amount of unburned particle in the smoke. I just burnt myself. Smoke acts as an excellent conductor for the heat back to the wick. The unburned particles in the smoke actually reignite the candle and bring the fire back to the wick. Pretty cool.
How many?
My next experiment involves a balloon, ordinary balloon, and a penny. Nothing special about the penny. That's what it happens to be for 1992, but it's just a penny. Now, for time's sake, I've already done what you need to do. What you want to do is take the penny and place it inside the balloon. Then blow up the balloon and tie it off like you would a regular balloon. So, start to swirl the balloon rapidly. Cause the coin inside to roll. The coin will roll for a very long time on a smooth surface at high coin speeds. The frequency at which the coin circles the balloon may resonate with one of the balloon's natural frequencies. and the balloon may hum loudly. Now my balloon, I can hear the humming. Hopefully it's picking up on the microphone. No?
You're making too much noise with the penny.
Too much noise with the penny, I've been told.
But I can hear it humming over here. I can hear it humming across the room.
So, that's experiment.
What is it?
Nothing really, just that. My last experiment here is showing Newton's first law. An object at rest stays at rest, and an object in motion stays in motion in a straight line unless acted on by unbalanced force. Right now, the pig is an object at rest. I don't see it moving, so obviously it's staying at rest. My next display of this law is a ball. The object in motion tends to stay in motion in a straight line. My last demonstration of this law kind of represents it as a whole. That an object that in motion will stay in motion in a straight line unless acted on by an unbalanced force. So, we have our guy, little guy Fred here. He's our volunteer. Sure he's not happy about it. So, it's also a demonstration that involves seatbelts. It's not the best one, but it demonstrates it well. Fred gets going at about, let's say, 10-15 miles an hour and hits the wall. Fred's dead. That's not good. Fred wasn't wearing a seatbelt. Now, the Jeep instant replay here was going. It was in motion, and so was Fred. But as soon as the Jeep hit the wall, it was acted on by an outside unbalanced force, causing it to completely stop. But Fred was in motion and had nothing to stop him, so he kept going and hit the wall. Poor Fred. Fred's dead. So, remember, seatbelts, very important thing to save you from Newton's first law of motion. Well, I hope you enjoyed my few demonstrations of physics. No, it wasn't much. To give you a brief example of the things you could do at home with the wonderful world of physics. Remember, buckle up.